In this video, we're going to take a look at two shortcuts that are going to help us save a whole lot of time whenever we're proving that triangles are congruent. We saw last time in class that it actually takes a whole lot of work. We have to show that three different angle pairs are congruent, three different side pairs are congruent. So that's a lot of work. That's basically 6 different congruent relationships we've got to show. So these two shortcuts will cut down that work quite a bit. They're called side, 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 and side angle, side triangle congruence. So we're just going to abbreviate as SSS and SAS. The way that they work is basically if you have two different triangles, if all 3 side pairs are congruent, this postulate says that the triangles themselves are going to be congruent. Basically, we don't need to know any angles as long as we know all 3 side pairs are congruent. Now, if we don't have all 3 side pairs congruent, or we don't know that all 3 side pairs are congruent, if we have at least 2 side pairs and what we call the included angle, that'll be the angle that those side pairs form. If those angles are congruent, then we can use side angle side congruence, which would be enough to show that the triangles themselves are congruent. So to show you a couple of examples, if we take a look at these 2 triangles here, triangle ABC and triangle FED, if you look at those tick marks, AB congruent to FD, BC congruent to FE, AC congruent to ED. So all 3 angle, or I should say all 3 side pairs are congruent to each other. So if we wanted to, we could say that those 2 triangles are congruent. So you could say triangle ABC is congruent to triangle DFE. Just pay close attention to those tick marks so you know which order to put those vertices in. If we take a look at these 2 triangles, I don't have all 3 side pairs congruent, but if you take a look, I've got 2 side pairs. SY is congruent to GD, SL is congruent to OD. So I've got 2 side pairs, and then the angles formed, those little arcs. Angle S is congruent to angle D. We call that the included angle. So as is, we could here use side angle side congruence. Now pay close attention to where those angle pairs are. For example, if I was to change the arc from angle D over to angle G, I could not use side angle side because the angles that are congruent are not formed by the congruent side pairs. So back to the original, think of the angle pairs, they're sort of sandwiched in between the side pairs that are congruent. So here we can use side angle side. Here we could not use side angle side. In fact, if we tried to, that would be like angle side side, and we're providing abbreviations to all of these. I'm not going to spell it out, but that gives us a bad abbreviation. So it's probably a hint that we shouldn't use that one. So let's look at a couple of examples when we might use side, 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 or side angle side. In this picture here, suppose that we know that R is the midpoint of TH and DY. So take a second, pause this video, try to determine if this should be a side, side, side or a side angle side congruence, or maybe neither. Take a second and do that. Okay, if you've paused and thought about it, if R is a midpoint, we could mark up our picture a whole bunch. TR is congruent to RH, but it's also a midpoint of YD, so YR is congruent to RD. That gives us 2 side pairs that are congruent. Also, remember all of our angle pair relationships. We have some vertical angles. So those vertical angles will give us enough to say that those 2 triangles are congruent by side angle side. Next, if we take a look at this one, where we know that, I need to skip over to this. So we know that BD is congruent to DS, and we also know that A is the midpoint of SB. Pause that video, see if you can determine if it's side angle side or side, side, side. If you thought about that one, notice that those 2 triangles share side AD, and every side is congruent to itself. That's that reflexive property. So if A is a midpoint, BA is congruent to AS, AD is congruent to itself, and we already knew BD was congruent to SD. So this would be a side, side, side. Why do these shortcuts help? Well, once we know that triangles are congruent, we learned in 4.3 that tells us all of their corresponding parts are congruent. So based on this picture, if we needed to, we could say that angle B is congruent to angle S, angle BDA is congruent to SDA, etc., etc., etc. That should give you plenty of information to get started on 4.4.